Today we are going to talk about evaluating expressions, but before we do that, I would like to review how each of these operations are written algebraically because you will see these different ways in our work today. So addition, just like always, we will see the plus sign. When we subtract, we will see our typical subtraction sign. Multiplication may be seen in several different ways. If there are one letter, one variable, and one number, or two variables, you might see them next to each other without any operation symbol. When you see them next to each other like that, that means that you multiply. You might see it with the multiplication dot, or parentheses might be used, and they can be used around one or both numbers. Now, with our work today, we might see something like this because we have a letter a variable and a number, but we might need to then switch it to this. I'll show you what that looks like in a moment. For division, we will see the typical division sign. We might see our division written as a fraction, A divided by B, or that backslash. Note here in multiplication that we never see our x anymore. Our x is now a variable. We no longer use it as a multiplication symbol. One quick review of the vocab word evaluate. This means to determine the value. So like if you're at the store, what is the value of this object? What is this object worth? What is that amount? What is that value? All right, so today we are going to evaluate algebraic expressions. What this means is that we are going to substitute. We are using substitution. So we are going to substitute a number for our variable. So the very first step will be to substitute our number for our variable. Now, we don't always just get to pick. Sometimes it'll tell us what variable that we are substituting in. And then after we've substituted in, then we use our order of operations and evaluate the expression. We find that value. So let's try an example together here. Now, we do want to make sure that we are keeping our work organized. I understand that a lot of these off the bat we can do in our heads. However, we do want to get in the habit of showing our work. If you do not show your work, then we don't always get full credit. Showing our work now when they're easier will allow us to better have a better understanding. So when they do get harder, we already know how to easily show our work. Okay, so our expression here is k plus 10. It says evaluate k plus 10 when k equals 8. Now we already know that 8 plus 10 is 18, but we are showing our work again for an easy problem. So we rewrite our expression, k plus 10. Now I take my k equals 8 and I substitute that 8 in for k. So I rewrite my new expression with that 8 substituted in. Now I have 8 plus 10. My second step is to use the order of operations to find the value of my expression. Here I only have addition, so I add those up. The value of k plus 10 when k equals 8 is 18. Now take a note for a second. Here I go line by line. I'm not going across saying equals, 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 equals. These are expressions, so remember we don't use that equal sign. We take our expression, we rewrite it directly underneath and evaluate going down. Let's try another example here. It says, evaluate 4n plus 5 when n equals 7. What is our first thing that we need to do? Well, we need to rewrite our expression. Now that we have our expression rewritten, what is our next step? It says that n equals 7. So I'm going to substitute n with 7. Now here we see that 4 times n. Okay, we know that the number, the coefficient, and the variable next to each other means that we're multiplying. When we rewrite our problem, our expression here, if I just write 4, 7 plus 5, it looks like 47. So I must add in one of my multiplication, my other multiplication symbols. So maybe I want to do parentheses this time. If you prefer the dot, you can do the multiplication dot. Whatever your choice is, that's fine, but make sure that this does not read as 47. All right, now I've substituted in, so I can use my order of operations to find the value. 4 times 7 is 28. Bring down my plus 5. Now I have 28 plus 5, which is 33. The value of 4n plus 5 when n equals 7 is 33. Now, it's important to note that this expression does not always have a value of 33. If I had a value of n that was different, perhaps I had a value of 10 here, and I substituted it in, it'd be 40 times 10 plus 5 would be 45. So this isn't the end value. It's specifically the value of this expression only when n equals 7. All right, we've got 2 more examples that we'll try. Sometimes we will have more than one variable that needs to be substituted in. So it says evaluate a divided by b when a equals 18 and b equals 2. Again, we know 18 divided by 2 equals 9. But again, we're going to show our work. We start by rewriting a divided by b. Now, step 2 is to substitute in. A equals 18 divided by b, which is 2. Now, I use my order of operations. 18 divided by 2 is 9. Again, a divided by b, when a equals 18 and b equals 2, our value of the expression is 9. We've got one more to try. It says evaluate, in parentheses, 8 minus x plus y squared when x equals 3 and y equals 4. I'm going to start by rewriting my expression. Awesome. Why don't you substitute in our variables and put your answer, your value of the expression, into the answer box. All right, so if I substitute in 8 minus 3 plus 4 squared, I use my order of operations, so I start with my parentheses. 8 minus 3 is 5 plus 4 squared. Now I am done with parentheses. I move on to my exponents, plus 5. Now all that I have left is addition. 5 plus 16 is 21. So the value of that expression is 21.